Okay, I'm going to kick things off. People might filter in, but as I say, we've got quite a lot to cover, so we'll get going. So thank you everyone for joining this session. It is being recorded, so if there is, if you do need to drop off at any point or you want to watch any of the presentations back, it will be uploaded to our YouTube and that will be shared afterwards. My name's Nicola. I'm a project manager at the Yorkshire and Humber AHSN. And in this session, we're going to be looking at estates and facilities, so covering things such as waste, energy, water, and ventilation. So it is going to be quite fast-paced and exciting. We've got a lot of really great people to present and speak to you today. And my job is to keep everyone's time. So apologies if I get a little bit strict with the timing. I just want to make sure that everyone has a chance to present and speak. So if you're not presenting or speaking, please do keep on mute, and if you can, put your cameras off just to save on the bandwidth. Please feel free to use the chat for any kind of discussions and the Q&A function for any questions, and we'll collate those. If we've got time, we'll answer them at the end. If not, we'll collate those and send those out afterwards. If you do have a question, please, if you could just put which innovator or speaker it relates to, if it's specific to someone, just so that we know who it relates to. So let me bring up our jam-packed agenda of speakers. So first up, we have Lauren from Loopcycle. So Lauren, over to you. Thank you.
Okie dokie. Good afternoon, guys. I'm just going to share my screen, which will probably take about 3 days knowing my luck, but here we go. Doing it. There we go.
There we go. We can see it.
There we go. It always likes to be a pain, doesn't it?
That was quicker than some that we had this morning, so you're not doing bad.
I know, but all of a sudden my heart rate shoots through the ceiling. So, good afternoon. My name's Lauren from Loopcycle. Thank you very much for the invite here. The AHSN are really big supporters of what we do, and following the group session roundtable 2, I now feel a massive amount of pressure. Loopcycle is a UK independent tech company. We are sustainability and AI specialists in mechanical assets. And what I want to talk about today is about commercial supply chains, data sharing and visibility. So since the day we started Loopcycle, we identified that there is a massive breakdown when it comes to communication and data sharing, which in the world of net zero and scope 3 maturity makes it really hard for the NHS to actually be able to calculate the emissions and the impacts of the products that they buy. The manufacturers don't know who they sell to, they don't keep a record, and historically maintaining inventories has been somewhat lackadaisical but not very technologically advanced. This creates a series of problems. So in terms of actually looking at the asset, knowing how long it lasts and how it performs, you don't get to know that. There's a loss of value in the product in its resale or reuse value, and it heavily hinders the sustainable procurement strategy with knowing very little about the equipment that you buy, the emissions and how it behaves or lasts. Our ethos is to connect buyers, supply chains, products and processes to create a 360 holistic view of net zero scope 3 emissions in manufactured products ranging from medtech to catering equipment and laundry. So in terms of the bigger drive towards net zero, you know what you're buying, when you got it and what the impact is, and at the end of its life, what you can do with it and how you can offset that. By incentivizing data collaboration across a value chain, we connect the value of commercial to the value and positive impact of sustainable choices. The NHS as an estate holder, whether that's trusts or whether that's clinics, can actually input live data across the lifespan of a piece of equipment. Using our bespoke QR code, which we call the cycle code, you can look at the stage before you buy it by using a panel, which is inputted by your manufacturers, and make decisions on, is it sustainable? What are the policies involved and how mature is the manufacturer? You can look at the in-use stage, which is, how does the equipment behave? Does it break down very often? Is there a human variable in that, which means that there's training and maintenance needed? And at the end of life, you can make decisions that have a positive impact, both financially and on the environment, by being able to look at 5 to 7 of the R processes, which allow you to prevent waste from landfill, but also prolong the life of the equipment and create a resource efficiency. One of our most recent projects was a pre-carbonisation project, shall we call it, working on a very, very large refurbishment in Canary Wharf. The problem that the end user had was creating a sustainable procurement measurement to ensure the equipment that they were purchasing was sustainable and that they could look at the carbon reduction and the carbon they were buying. By answering simple questions and gathering simple pieces of data from manufacturers that historically are unheard of, we were able to support 74 manufacturers to become or get on the road to sustainability and be able to provide data that they unknowingly didn't recognize as being sustainable. Within 12 weeks, we managed to do a complete insight of the equipment manufacturers, but we also managed to essentially accredit the manufacturers where they were on a sliding scale. That included responsible sourcing, water consumption, end-of-life policies, and their willingness to even participate. Asset management in the NHS is varying. It can go from being on a portal, it can go from being on a spreadsheet, or it can go on being on a piece of paper. To achieve net zero, the NHS needs to know what it has, how long it's had it, does it last, and what is it costing itself at the end of life. Referencing one of the presentations earlier, when you are looking at your energy management, that plays into the equipment that you're actually buying, with 20 to 40% of the energy consumption being aircon and HVAC. Surely that states a case that all mechanical equipment holds a significant contribution to the NHS's net zero footprint. In terms of where the NHS is at the moment, it's very much driven the NHS Evergreen policy, which starts to measure manufacturers, but having that information available and a partner to be able to put that together for you takes a lot of the legwork away and also gives you an independent viewpoint of how you can become more sustainable, one asset decision at a time. Imagine walking around your trust, your site, a ward, and knowing that everything is recorded, everything is traceable, and everything has an end-of-life plan. By creating a supply chain ecosystem, we can connect sites, users, nursing staff, and manufacturers together so they can interact in a valuable and meaningful way through a digital inventory. But your manufacturers can support your sites, your budgets, and your net zero goals by looking at your data, reviewing your data, and redesigning their products long term. The net zero case for life cycle traceability is actually very interesting. And as much as energy efficient and energy reduction is very, very important, the traceability side of it is a very big CapEx spend and a very big emission spend. Looking at resources, looking at resource efficiency, and looking at the energy used in production, the NHS purchases from all over the world. It purchases assets ranging from a toaster all the way to an MRI scanner. Each one has an end-of-life possibility. Each one uses a massive resource. And in terms of net zero, looking at figures such as 70% in resource savings, it begs the question, what can the NHS do to firstly become more circular, but secondly, reduce its raw material extraction and benefit the environment? By creating a QR coded system and tracking provenance of all assets, we can not only measure how much you're buying, but also using our bespoke embodied carbon calculator, we can look at the carbon when it arrives at site through A1 to A4, but also the logistical carbon. If you're purchasing products from other countries, what does that look like? But also, can assets be moved between trusts and between sites at the end of life when they're no longer of use? Is there another site or another trust that could utilise that piece of equipment? By diverting that from landfill, you can save on carbon, but our emissions calculator for transport can also track its location. Operation excellence and operational efficiency is a big driver towards Scope 3. If you don't know where products are, you don't know what the product looks like, and you're not keeping track of its service history, you are automatically losing control of Scope 3 emissions that can be resolved quite quickly. By creating our system, we installed a service tool into this, which gives essentially every single product that goes into a site a birth certificate, a passport, and a medical record. By understanding how a product performs, how well it's maintained, and how often it actually fails, you can start to not only review, is it the right product that you're buying, but also what are the behavioural changes that can be made on sites that can reduce unnecessary emissions. And by that, the easiest way to explain it is an engineer call out. If you can quick look assess on a range of products or a piece of laundry equipment, that product keeps breaking down because it has a scale problem, you can firstly eliminate that problem, but secondly, prevent it from happening across your estate by addressing those challenges, in turn, providing an emission saving, but also a financial saving. We worked with an NHS trust, in Cambridge on their phlebotomy and laboratory grade fridges and freezers. They own their equipment, they service their equipment and dispose of it at the end of life, which, as you can imagine, with 70 or 80 freezers is a large cost, and it's also a large environmental impact under BREEAM, but also embodied carbon. We found out coming out of this side that there were actually more fridges and freezers on the estate than was first thought. There was no real easy way to organise maintenance, so at the end of life, the unit was disposed of. There was no carbon measurement, and there wasn't any ability to extend the life, recycle, or even start to review the end of life for any of the fridges and freezers. The standard solution was to scrap it and buy a new one at a cost of £6,500 per unit. By working with the trust and by highlighting these cycles, what we found was creating simple data touch points such as user documents, who the service partner was and how often it should be maintained. The potential was there to reduce costs, but also interact with other manufacturers that could support the NHS trust in question in a better way, but also start exploring circular end-of-life solutions to prevent any product that was truly at the end of its life within the estate from going to waste. Circular economy is at the core of what we do. We are very much about traceability and about life cycle extension, but we are huge believers that every product and every material doesn't just have one life. We've created several different routes to keep equipment into a life cycle rather than just one and it disappears. We created the Loopcycle marketplace, which can be internal or external, so you can share between a trust. If there is a table and microwave or a HVAC system from one strip out that could be reused elsewhere, we facilitate that by creating meaningful interactions across the supply chain, but also within trusts. We've also created a social value where products can be donated, and that can be to other members of the platform, or it can also be traced and measured outside. And by doing this, at the end of life, we don't just say, this is what you did with it, congratulations. We've created a waste and end of life model that will measure the meaningful impact of firstly tracing the equipment, but at the end of its life, being able to say, this is what happened to it, and put a number to that carbon saving. We are heavily working with manufacturers at the moment and have seen a lot of step changes within supply chains that manufacturers are very much switching on. And they are realising that to support the NHS, they need to do better. By creating a QR code that connects them to your sites, you can tell them at the end of its life, we'd like something to be done with this equipment. They can create sustainable processes and also begin to eco-design. I will share this deck so we can see we do a lot of work outside of the NHS with a well-known brand called Nando's. And by just giving them options, we managed to save on 9 redundant units 38% of the carbon, which works out at just 2,500 tonnes and delivered a saving of purchasable parts of about £10,000. We work with the manufacturers, as I've mentioned, and each of these manufacturers get a scannable code, which is live. And this creates a full diagnostic of the equipment, but also a really easy access area for all the documents that their end users need to get the best out of the equipment. By using our platform, the manufacturers can learn more about you and can support you better and become a partner to reduce your emissions. So we are innovative, we are groundbreaking, and we're here to resolve the data gaps that you have, and we're here to support you guys. We're here to be able to show you that you can do more with your equipment, and that net zero in assets and that supplier maturity can be achieved, and we can help you achieve it and make it as painless as possible. Thank you very much for listening. I hope it wasn't too much to take in.
Thank you, Laura. That was really interesting. Fantastic. Thank you. Lots and lots to take away there.
Thank you very much.
So we will move on. As I mentioned, we are short on time, but please do use the Q&A or the chat function to continue discussing with Lauren if Lauren's able to stick around. And we'll try and answer any questions either at the end, or we'll send out a Q&A afterwards if we run out of time. So moving swiftly on, do we have Simon from Dalkia on the call?
We have Rob from Dalkia.
Oh, we have Rob. No problem
yeah,
at all. Thank you.
No worries. As I said, there's a bit of crossover, I think, on that one. But yeah, let me just share my screen and you can jump straight into it. Is that come through?
See that. Yeah.
Perfect. So good afternoon, everyone. My name's Rob Sinclair. I work for Dalkia Energy Services, and what we do is effectively a projects business and a solution integrator on decarbonisation of NHS hospitals. So that's our kind of bread and butter and our expertise. And what I wanted to do was kind of share with you some of the best practices that we do from a project side and experience that we've learned on decarbonising hospitals, as well as some of the innovation that we're looking at introducing off the back of decarbonisation projects, which hopefully kind of answers that question of can you really decarbonise, reduce operational costs and improve the patient experience as well. So I'll dive straight into it. So just in terms of some of the challenges that we generally see with some of these projects and why they struggle to sometimes get going, especially when we're talking about innovation and digital technologies, is that in many cases the trusts are quite segregated in terms of responsibilities. I think that is improving now with the nature of stakeholders such as digital matrons to help bridge that gap between estates and clinical care. We also see challenges around poor existing infrastructure, in particular around existing electrical infrastructure as well, that can limit projects. Limited expertise or awareness of opportunities or technologies. I mean, part of today is to help try and bridge that gap and provide information to people within the NHS of what's out there. But again, I think there's also limited, in some cases, expertise around what can be done. Ongoing issues around difficulty absorbing operational increases, decarbonisation of hospital sites, especially electrification of heat, can add costs to OpEx budgets as well, which are really strained. And then again, another ongoing issue is around limited or no capex for estates projects as well, or difficulty prioritising those. So there's some of the issues that we definitely come across and hopefully resonate with some of you on the call. And again, what I wanted to address in kind of maybe a best way of doing it is in an actual case study, and we've got kind of multiple ones of these, but this is a really nice example. We work with North Tyneside General Hospital, part of Northumbria Healthcare. essentially a year or two ago, we started this engagement with the trust and the hospital, and this really kind of tackled multiple aspects of those challenges. So the first one was around capital. And what we did was help secure, first of all, some capital funding through the public sector decarbonisation scheme. If you're not aware of that, that's a central government grant that's been running now for about the last 2 years. There's another phase of funding coming up next month, which will allocate roughly another £500,000 to the public sector to support decarbonisation. So if you're not aware of that, definitely look up PSDS, Public Sector Decarbonisation Scheme. There's also, again, we looked at innovative ways of decarbonising the site. So again, the typical approach for decarbonisation with many historical projects is to look at them as a case-by-case basis. So you do your lighting, then you move on to your next project, do some solar PV. But what
You've just gone on mute, Rob. Not sure what's happened there.
am I back
There we
again?
go. You're
Perfect.
back.
Yep. So I was just saying that we took a whole building approach. We looked at innovative ways of generating heat whilst minimizing operational costs. So we did that by utilizing both energy efficiency and solar PV, all part of one business case. We looked at things like or implemented ground source heat pumps as well, which are more efficient than air source heat pumps. So we also looked at incorporating the backlog maintenance numbers into this and looked at how does the decarbonisation project not just affect the carbon output, but if you're de-steaming a site or if you've got lots of maintenance challenges, how can that project help resolve some of those issues that you've maybe had going on for a number of years, and how does it also tie in with the clinical benefits as well? I had a great example at an NHS England meeting last week, and they'd used replacing windows, which sounds a very dull and boring project by itself, but how did that benefit clinical care? And specifically, this was around the neonatal unit, which historically it had challenges around skin-to-skin contact between mother and baby because they couldn't really control that building environment particularly well. By replacing old single glazed windows, they reduced drafts, and it just made the clinical experience better. So again, thinking around how does it not just impact carbon benefits, but how does it impact clinical care? And that's, again, some of the things that we looked at on this project to really make it applicable to the wider stakeholders. So again, I won't go through everything in detail here, but we looked at a range of measures to improve the hospital, and then implemented it with the PSDS funding initiative. And then this is in terms of helping meet that net zero carbon pathway. Essentially, what we've done with this project is a 70% reduction in CO2 by 2027, and then effectively what we'll see is a decarbonisation anyway of the electricity grid. So what you can then do is have a very low residual amount of gas in the grey, gas-related CO2, which again can be offset with either certificates, or as technologies change in the future, we can look at adapting existing infrastructure there as well. But in terms of then how can we also use decarbonisation to deliver innovation and on that patient experience and further cost saving? Essentially, there's lots of manufacturers, and we're from our side manufacturer agnostic. We don't necessarily have any preferred technology partners, but this is a really nice example by a company called Enlighted that's owned by Siemens, and they manufacture these smart sensors, And these smart sensors are actually installed as part of typically a lighting project. They can be retrofitted into ceiling spaces, but they're literally size of a golf ball. And what they can do is further optimize the lighting and room controls. So what you can do is get additional energy savings and cost reductions through further optimizing the lighting controls. They also have temperature sensors within the same single sensor. So what you can then start to do as well from this one installation is start to get better control around heating and ventilation, which can drive further savings. You then start to get other benefits as well, such as the emergency lighting testing that can be done, can be automated as well as part of this sensor. And when you start building these in and you're controlling the lighting in a much better way, you can start to extend the lifetime of those lights. And it also means that you're not spending as much time on the operational and maintenance costs. And that isn't just around the lighting unit. If you're running your HVAC less because you're not heating and cooling areas that aren't populated or in use, then again you're going to get all of these additional benefits within the extended life of the building infrastructure. And then in terms of what does that mean from a use case and how does that feed into the clinical side, because these sensors also have Bluetooth incorporated in them as well. What you have is these Bluetooth tags that also communicate with the sensors, and you can start doing kind of lots of other additional user case and benefits, which include just some examples around asset tracking. So you can tag hospital equipment and find out where a piece of equipment is within a hospital. You could potentially track things like patient from ward to theatre and have those respective check-in points as well on that patient journey on the clinical side. You can protect equipment from going missing as well, and you can have alarming capabilities, and you can also have things like understanding where people are within the building, such as porters as well, which all just helps optimize that kind of clinical side on the workflow. And just within this is just some examples of the Enlighted software. So this is specifically around if hopefully this animation is running for you on the left-hand side. This is just again trying to identify where a wheelchair is, for example, within a hospital environment. This head end would be accessible to porters, nurses, doctors, anyone that would need access to it. And again, it can be used for multiple kind of use cases. And again, all of this comes from going back to the original point of a decarbonisation project and the installation of some lighting and some tags. Again, what we can also do within these sensors, you've got opportunities around space monitoring. So at the moment, there's certainly a push from NHS England to better understand non-clinical areas and how that's being used. At the moment, the clinical side, a lot of hospitals are at capacity. So is there an opportunity to understand how the non-clinical spaces are utilised? Could they potentially be repurposed? You could also look at areas of understanding, again, patient flows, patients in waiting areas such as A&E. You can look at clinical pathways as well, understanding how patients go from one diagnostics area to another. Again, lots of potential use cases that can be done as part of this technology interface. So really kind of what we would say is part of the overall I guess approach to decarbonisation, but bringing in the innovation and the benefits side there, we'd say take the whole building approach. Again, it's the best way of getting multiple improvements in across an estate, look at building fabric, look at energy efficiency, look at the supply side, which is around, again, heat pumps, solar PV, but also look at the use cases around digital solutions, such as the ones that I've just covered off on my presentation. So I think hopefully I'm within the time limit, and obviously if there's any questions, I'll be on and look forward to hearing from you.
Thank you, Rob. Bang on time. Well done. Thank you. That was really, really fascinating. I really liked the animations that kind of bring everything to life. It was, yeah, really interesting. Thank you. Do continue to use the chat to connect to Rob or any of our speakers, or the Q&A to ask any questions. But I can see we've got Lisa from Eco Heatwave. Hi, Lisa. Thank you for joining us, and I will hand over to you.
Okay, hello Nicola, and hello everybody on the call today. Thank you for having me here. I'm really excited to sort of show you a little bit about what Eco Heatwave is about, and I'm just going to see if I can get this presentation up. I know that Rob and Lauren will be hard acts to follow because they were really organised in getting that ready. So let's see if we can get this presentation rocking. There we go. So hopefully in a moment you'll be able to see that.
Just loading. There we go, it's up now.
Oh, you've got that right, okay. Okay, so Eco Heatwave provides a hidden heating solution that doesn't cost the earth. So we believe that there's another way to heat our homes and our spaces that would provide better air quality and positive health outcomes. I know a number of people have mentioned about when looking at new technologies, it's about also considering what health outcomes you can get along the way too. So when considering sort of setting a scene, I just thought there was a few interesting pieces of information there about, I'm kind of coming at this from a slightly different angle because we have a product development coming sort of in the springtime of 2024 that would be more relevant to the hospital setting and GP surgeries, for example. But we have been really looking at this from a let's tackle cold homes and let's help the NHS save some money. I know that the NHS have recently trialled heat as a prescription in conjunction with the Energy Systems Catapult. It was really interesting to see some of the anecdotal evidence supplied in their videos from people that had benefited from this prescription. It was quite shocking to see actually that when considering paying for somebody's heating in the home for health benefit reasons, that the actual methodology of the way that the heat was deployed in that home wasn't really considered. There was in this particular video on the case study website, a couple that were talking about their experience of receiving this prescribed heat. And in the background was this really old and decrepit electric radiator that would have been a really aggressive way to heat that space in terms of the way that it affects the air quality within the home. So obviously, everybody's looking to move away from centralised heating options and anything that involves gas. And so really now there is an opportunity to switch to healthier electric forms of heating, and we believe that Eco Heatwave can be a great solution to that. Our solution's cost effective. It's inexpensive to as a solution as a whole. So for a 3-bed property, you're looking at around £3,000 for the materials. It's not particularly expensive to have that installed either, but we do have kit formats for any new build properties that would make that even quicker and more cost effective. Your electrician can be trained to install our type of products. So any electrician out there that provides us with the correct documentation for their insurance, etc., would be brought on board as an installer. So it's not like with heat pumps, you've got to have somebody very, very specialist and costly. It is something that any electrician can be trained to deliver. Once it's installed, it requires zero maintenance, and the lifespan of the product, because there are no moving parts, is deemed to be in excess of 25 years. There are reports from the manufacturers, they expect it to last around 50 years. The image just in this photograph here, it's the Eternal Garden pod within St Peter's Hospital that we installed the heating system to in 2022. It kind of was a great way in which the green environment was incorporated into sort of a scheme for end of life. I don't know if any of you would be interested in having a look at that, but the feedback we've had from that has been excellent in terms of a heating method for sort of a building that would be outdoors, but potentially the outdoors indoors. So having the doors open, you're still able to generate heat within that space. So the heating system itself is a far infrared heating system. And for those of you who don't know what far infrared is and how it works, it's a long wave invisible light that's very, very safe. We naturally absorb and emit it anyway. It's very similar to what you would receive from the sun. So I know we've had some sort of delivery from other companies, like the chap earlier about the sunlight being brought into the hospital. There are lots and lots of health benefits to natural light, and far infrared is essentially a kind of an extension to that, really, except our heating system doesn't generate any ultraviolet rays. Far infrared has been used in special care baby units for decades, so it is known to be safe for sort of human use. It works very, very differently to your gas central heating systems, your centralised heating systems. I know a lot of people are talking about using heat pumps, but typically they deliver the heat in a similar way in that it's very aggressive in the way that it delivers the heat to the space. It tends to be heated air that is being circulated and generated from the heat source. So that actually surprisingly does propagate a lot of movement of dust and allergen particles in particular. You'll see that on a sunny day when the sunlight's coming through the window, you see all the bits floating in the air in the winter when you've got your heating on. And that's what you typically get with your gas central heating system, for example. We all know this from school. We were all taught that heat rises, but in actual fact, it's the heated air that rises, not the heat itself. Because air's a poor heat conductor, what you find is that with these types of convection heating systems, all your hot air and the money that you're putting into a space to provide heat to it tends to sort of end up at the ceiling, and that's where you're going to feel the less benefit. So also at the same time, traditional methods would basically provide, because typically you've got the heat rising scenario and it swells up. Obviously you've got your warm, moist air meeting a cold window, for example, and you've got your condensation, your damp, and then your black mold can form, which obviously then impacts health as well. When you open a window or door with a convection heated space where you're only heating the air, that's all it's really doing. The minute you open a door or window, all the money that you've put into that space to heat it is going to essentially go out the window or the door. So there is another way. So far infrared works completely different to that. So it primarily heats the fabric of the building and the people within it. And what we find is that there's a very even distribution of heat across the space. So if your thermostat that's monitoring the temperature of the room tells you that it's 21 degrees, for argument's sake, every point, whether it's an external wall, a window, or anything that you might, or the floor, you're going to find that the temperature would be exactly the same throughout. So within a couple of degrees, every sort of surface that you would put a temperature gun to would temp at the same. It's almost like it's a very subtle delivery method. So it's a little bit like on a sunny day when sort of a cloudy winter's day and the sun comes out from behind a cloud and you feel the warmth despite the air still feeling cold. It has that methodology around the way that it's delivered, but you do end up with a fresh air breathing sensation indoors. And what it does is, so all that money that we're putting in by deploying the energy in the space that then builds thermal mass within the fabric of the building, which when we open that door or window is much more difficult to dissipate. So it would only be the secondary warm air that we create with far infrared that would escape in exactly the same way as the alternative methods. However, a high proportion of the energy that you've put into that space would be retained in the objects and the furnishings. So what we find with this is that often you've got an increased personal comfort at lower temperatures. We know from the government's own statistics that to save just 3 degrees, turn the temperature down just 3 degrees is going to save you at least 30% on your energy bills. So because this type of heating actually heats the people within the space and they're more comfortable at lower temperatures, you could instantly benefit from those savings. It uses less energy, and one of the things that we think is really important in our race to net zero is just to strip everything back and just keep it simple. At the end of the day, we can achieve it if we use less energy. So yes, there are lots and lots of different solutions out there, but if we just use less energy, that's going to really help. And this is a method in which you can use less energy. With the even distribution of heat, obviously the thermal mass builds steadily within the space and it's retained. We've got examples up in the Grampian region up near sort of Aberdeenshire. There's a gent who's got some musculoskeletal issues and circulatory issues who's been on medication all his adult life. We switched out our heating system for his old gas central heating system. Very, very simple retrofit into his bungalow. Did in just one day. And essentially within the first week, he was already reporting increased comfort from a circulatory perspective. So he was reporting that he was taking less pain medication already after just 1 week, which we were quite surprised about. So with far infrared, we talked about the convection methodology providing sort of the optimum sort of environment for your black mold, damp and condensation. You don't get that with far infrared. So if we would temp gun our window or our external wall, for example, where often you would find these growths in the depths of winter, what you'll find is either the window will be the same temperature as your thermostat is saying it is, or it'll actually be higher because there'll be some solar gain from the sunshine outside. So it doesn't promote the environment for that to occur. So therefore, it's one less health risk to be concerned about by deploying infrared. So it not only protects the fabric of the building, but also you've got that fresh air sort of breathing sensation within the home. It was interesting recently that we were in a building previously that we were using for our office space, and there were probably 50 other rooms in the building, and they all use the Mitsubishi type aircon units that were able to deploy obviously cooling and heating. What we found was we actually saw with our own eyes the difference between a room heated with infrared and a room heated by sort of a convectional method, in that despite using this aircon unit all the time in our demonstrations, sort of after clients had left, we would bring the temperature down because it was too hot for us to be comfortable. The gent came to service, and basically every other room had a really dirty black filter that had to either be replaced or cleaned. Ours was completely free of any dust particles whatsoever. It was completely clean as the day as it went in. So that was really, we knew the science about the fact that infrared, although it heats the air, it does it secondary, so it doesn't have the inertia to pick up all those muck and dust and allergens and circulate them within the room. But that was really the first time that we'd seen it. That was really exciting for us. The heating system itself is really unassuming. There's a picture there of our Eco Heatwave heating film that's designed to go in a suspended ceiling. It's very unassuming. It literally is a flexible heating system made up of just a few components, sort of 5 different components really. And we back it with a reflective insulation, and we can deploy it in 25 centimetre increments. It's a low surface temperature device, so it's designed not to get to temperatures above 48 degrees. and with no moving parts, obviously then you've got that increased lifespan. And the way that it deploys the heat is we would usually put it in the ceiling, and we would spread it equidistant across the space that we've got to heat the room, and then that's how we get the really even distribution of heat. Some of you may have seen infrared panels previously. They offer obviously far infrared solutions, but the difference between the two is vast in that they deploy higher surface temperatures over a small surface area. Therefore, they can often struggle with that even distribution of heat. And then when you consider the health benefits that we can get from far infrared, sometimes with the high surface temperatures, it can feel quite aggressive to the occupant. So by doing it in a more gentler way, using the lower surface temperature technology, we can basically get the best of both worlds. It's very quick and easy to install, as I alluded earlier. We put between 30 and 50% area coverage into a ceiling. We can do this in new build and retrofit. And we do offer installer and specifier training. So anybody that's interested in either being an installer down the line or learning how to specify, we do have our own bespoke calculator that can help size a space. We can fit it from above or below, depending what we've got. And it's really super easy to pop into suspended ceilings. When we're thinking about the domestic setting, some customers we've visited are happy to drop their ceiling an inch by cross-battening and concealing the heating system within a dropped ceiling. Some want it in the floor. So there's a number of different ways in which the heating system can be deployed. This is some of the methodology that we would use. So you've got some examples within domestic settings of in-ceiling from above. In-ceiling from below image there is, that's actually the St. Peter's project. Then there's the underfloor option where you basically put a wider coverage of product into an underfloor install. And then coming soon, we are in the process of collaborating and innovating with regards in-ceiling installations in the suspended ceilings. So whilst we can put our heating film in, as you saw in the previous picture, busy hospital ceilings could be problematic if you've got people up there on a regular basis for servicing and maintenance of other items. So we're actually putting the product into some sealed in-grid ceiling panels, and that should be ready sort of early in 2024. They can simply be popped in place and with a male-female connector block, similar to what the lighting manufacturers use, it would simply be clicked into place. So very, very easy to install for those. And obviously they can then be taken out and moved elsewhere if there was reconfiguration of any spaces as well in the future. So there are many efficiencies with this. So the way that the film works itself, it takes in...
Lisa, I'm really sorry to interrupt you. I might need to wrap you up in a minute. We're just slightly running over, but yeah, carry on.
Yeah.
We just, maybe got another minute.
Okay.
Thank you.
Well, I think so there's a number of ways in which it's efficient in the way that it delivers the heat and the way that you can control it. So it's a completely decentralized heating system that uses sort of smart technology to control it. And essentially, it removes a lot of other risks that are commonly related to the way we heat our spaces. But I think what was really exciting for us is that there's lots and lots of emerging anecdotal evidence from customers to say that they are actually having improved respiratory health, improved musculoskeletal health as well. So we're really enthused and encouraged by that and looking at ways in which we can sort of carry out larger field trials to prove that further, particularly if we're looking to go ahead with the trying to get in on the heat as a prescription side of things. But it is suitable for hospital settings, doctors' surgeries, etc. in its current form and in the panels that we're launching very soon. So we'd welcome any discussions with any sort of existing suppliers to the NHS or anybody that would be looking to incorporate it into any future projects. And just one of the key things that I've not really mentioned up to now is that the way we've set up Eco Heatwave, we are able to provide a subsidised product to public sector organisations. So that by way of a linear meter, for every linear meter that you require for a project would be donated. so that we hope to make a really positive impact. And we recognise budgets are tight, but this is something that can really make an impact on those carbon emissions while still actually increasing the well-being and the health benefits of the occupants as well. I'd welcome any questions from anybody or any contacts after today, and thank you for listening.
Thank you, Lisa. Apologies for needing to rush you at the end. We just do have quite a tight.
I'm on my own, so I'm so sorry about that.
No, don't worry at all. That was really interesting and really good to hear about the balance between the kind of environmental sustainability aspect and the patient benefits in terms of the respiratory and pain management benefits too. So thank you. And yes, please do connect with Lisa if you'd like more information.
Okay, thank you for having me.
You're welcome. Thank you. So next up, we have Nic from Blockdox. So thank you, Nic. Thank you for your patience while we're just running a little tiny bit behind, but we'll have time, I'm sure, to fit everyone in. So I'll let you take it away, Nic. Oh, you're on mute, Nic.
Good afternoon, everybody. Can you hear me?
Yes, we can hear you and see your slides. Thank you.
You can see the slides as well?
We can. It's going well.
Oh, that's a bonus. Great. Fantastic. So let me put it on a presentation view. There we go. So good afternoon, everybody. My name is Nic Shulman. I'm the CEO and founder of Blockdox, and I'm going to talk to you this afternoon about our product Area View and how it can help hospitals with their achieving net zero. So first of all, I'd like to set some context. The NHS, as some of you may be aware, has published this document delivering a net zero national health service, and identified that the climate emergency is a health emergency. So the NHS has become the first health system to actually embed net zero into legislation, thanks to the Health and Safety Act of 2022 last year. And within the NHS, what might be less well known is that the NHS estates and facilities is actually responsible for 15% of total carbon emissions. That costs for running the NHS £8 billion a year, which is the third largest NHS cost after workforce and drug expenditure. So improving the way the estates and facilities operate not only has a major impact in achieving net zero, but also delivering savings, which can then be reallocated to frontline services. So the NHS themselves have actually identified that there's opportunities to improve operational efficiency from things like heating, ventilation, air conditioning systems, and so on. That's predicted to save £250 million a year, each year over the next 5 to 10 years. And then by introducing real-time energy monitoring and control, including the use of artificial intelligence, that could contribute an additional 2.3% of the total required reduction in carbon emissions. And that in itself could deliver net annual savings of £120 million per year over the similar time frame. Now, against that context, it's also key to understand the role that indoor air quality plays in achieving net zero. So air pollution is actually the world's largest single environmental health risk and the cause of every 7th death worldwide. But what's sometimes overlooked is that people spend around 87% of their time indoors. And so whilst a lot of the focus has been on outdoor air pollution, actually indoor air quality is more dangerous than outdoors. And the reason for that is because the pollutants can become trapped inside buildings with inadequate ventilation. And within a healthcare environment, such as hospitals, but other healthcare buildings as well, that's obviously, not going to be satisfactory. Indeed, last year, I believe the chief medical officer identified and succinctly put it as follows, that maximizing ventilation whilst keeping buildings warm in winter and cool in summer and minimizing energy and carbon is this critical engineering challenge, which is absolutely central to reducing unavoidable indoor air pollution and is an important difference from addressing outdoor air pollution. So against that context, we identified that actually the most dangerous risks to buildings and the people that use them are actually those unseen. This is indoor air quality, space utilization, and energy consumption. Three key foundation points which are absolutely vital to delivering net zero ambitions. So area view actually makes the invisible visible. And what we do is we gather data anonymously from sensors and a range of other sources. We aggregate that data together, and then we produce crucial insights to help our users manage their spaces more efficiently. And we do that through three key methods. First of all, push notifications, but we also have an API and a dashboard interface as well for more deeper reflective investigation. So, we work on the principle that, you can't mitigate what you don't measure. And there's a range of metrics which are really important in that regard. First of all, once you understand your real-time occupancy, then you can enable spaces to be managed according to demand rather than purely against time. And then that leads into being able to do proper space utilization studies, because inadequate spaces only causes higher property and operating costs from the management of either unused or underutilized spaces. And then, there's a whole range of air quality metrics, just picking a few of these, which are absolutely critical. So first of all, CO2. Higher levels of CO2 affects concentration, can cause headaches and fatigue, and other minor health issues. Noise impacts productivity, and we've heard frequently doctors and nurses complaining about having quiet places where they can sit down and work. Humidity, that can cause mold and bacteria, which not only has an impact on the building fabric, but also health effects as well. Temperature, that can again affect the productivity, but also create those conditions where viruses thrive. PM 2.5, that can get into lungs and blood, causing illnesses, especially where it seeps in from outside, such as main entranceways to hospitals, as well as delivery bays and so on. And then how do we mitigate all of these energy indoor air quality issues? Well, usually the obvious way to do that is by opening a window and letting fresh air in, but that's not always possible, particularly in the most common types of buildings today. And that's why we have artificial means, such as from HVAC systems. But if those HVAC systems are running continuously, there's an energy cost to that. And so by managing energy costs according to actual demand and based on measuring air quality, it offers greater opportunities for savings. So what we do is we aggregate data from a whole range of different metrics. We're integrated with 5 different types of occupancy metrics. So this isn't just a footfall count, but also includes occupancy, presence, people flow, and dwell time. 23 air quality insights, the obvious ones being temperature, CO2, humidity, but some of the more specialized ones like PM 2.5, volatile organic compounds, and so on. And then 7, energy and other insights, such as outdoor weather conditions. And then we can deliver that information in a range of different ways. Just to give you an example of a few of those, public-facing displays, such as those which could be displayed in receptions or lobby areas. Actionable insight reports, which are either single metrics, such as just occupancy, or combined reports, such as energy, air quality, and space utilization. Because the key thing for the end user is they want to know what's wrong and what do we need to do about it, not necessarily to have to do a lot of the interpretation themselves. So that's why we also deliver push notifications by email to let our end users know when thresholds have been breached or there's an issue, so they can take action. But there's always dashboard views where a more reflective or deeper dive into the data is still possible. So here's an example of one for space utilization occupancy, another one here for indoor air quality. So where you can see each panel is for a different space, and within that space we have provided an overall indoor air quality score, but at a glance you can immediately see in the yellow dial a humidity issue in that particular space, which means that can be prioritized for an intervention. And related, obviously, very closely to net zero is the ESG and sustainable disclosure reporting. So traditionally, reporting energy efficiency purely based on utility consumption was satisfactory, but that's no longer the case. And being able to understand granular energy efficiency per building is now really imperative, but that information is obviously really difficult to obtain, and consequences can be quite serious. So we can actually help with that, and we're big advocates of the correct measure being an occupancy intensity, energy intensity per occupant data point, because that better shows a benchmark between buildings and the energy usage based on how they're actually being used. We've already done this in hospital and non-hospital environments, where we've been able to identify for our users very significant energy, but also other savings, including operational savings, as well as from space utilization as well. Very used to working with very large enterprise level organizations. So just concluding with a case study, we've had experience of working in healthcare environment. Is a hospital where we were tasked with looking at how net zero, how we could support their net zero policies through space utilization, air quality insights. And we were able to install a variety of different types of sensors in clinical and non-clinical environments. And we actually measured over 8,200 triages within just 6 weeks with very high accuracy points. And by doing so, we were able to show this particular hospital their busiest, least busy times and days, and the duration of the triages and the inter-triage duration, which not only improved operational efficiency, but this underpinned thinking about the net zero strategy and when those estate and facility services were actually being delivered and how they could be moderated in order to make improvements. There are many different types of spaces where this is applicable within a hospital environment, aside from the pure clinical areas, such as waiting rooms and reception spaces and so on. And aside from the pure energy saving, as you can see here, there are many other opportunities for delivering benefits which deliver an enhanced ROI and make it a more compelling business case for adopting this type of technology. As I said at the beginning, in NHS England's own the payback period for using AI solutions such as these is actually very, very short. And we were really proud that we have very strong sustainability credentials. So we've actually had our climate impact independently validated and certified by Impact Forecast to show that actually we can help our end users save over 1 million tons of CO2, which is equivalent to approximately the size of Barbados in forested area. Finally, the Mayor of London selected us as winners of his Air Quality Challenge, and last year we were shortlisted for the Net Zero Impact Award at the Energy Innovation Awards. So we're very committed to this sector and helping people achieve their sustainability goals. So hopefully, Nicola, I made up a bit of time there. Thank you for listening to my presentation. Not sure if questions are appropriate, but if not, then here is my email address. Please do get in touch if you have any questions or if you'd like to know more. Thank you.
Brilliant. Thank you, Nick. Really, really interesting and insightful presentation. And please do connect with Nick if you'd like any more information. Just for anyone joining us, we are running very slightly behind schedule, so thank you for bearing with us. We've had a whole lot of really fascinating and interesting information to cover, so bear with us while we are just a little bit behind schedule. But next up, we do have, I hope, Peter from Energy Optimisation. So if Peter is there, or if it's not Peter, one of Peter's colleagues, please, I'll hand over to you. There we go, we've got Peter. Thank you, and thank you for bearing with us with the timings.
No problem at all. I'm going to shut down my screen so that I can share a slide deck with you. Thanks everybody for your time this afternoon. I've got a couple of colleagues with me, Brian Clavin, who is responsible for our relationship with AHSN, and also Paul Graham from the Kingston Hospital NHS Trust, who is our point of contact and our sponsor for our first NHS project at Kingston upon Thames. So let me just bring up some slides, and hopefully you'll be able to see those. And I'll just start the slides from the start. So my name is Peter Walker. I'm a director and shareholder in EOS, and we specialise in the installation of fully funded sustainable energy optimisation facilities. We utilise the latest battery-based energy storage technologies, which we call BESS, and also on-site renewable generation, which we refer to as BESS Plus, and the control systems that go with that. These are a non-disruptive containerized solution, so they're very much off-site fabricated and plug and play on-site. Notionally, can also add another layer of resilience to electrical infrastructure. So we create flexible, secure and dynamic charge and discharge protocols that can deliver, through the use of the BESS and the generation, a shared savings and revenue model. The other big advantage of this type of approach is through carbon reduction. We operate under a long-term property lease, 15 years, because we're going to be recovering our investment, and we then make variable rent payments to the host that are in accordance with the split that we've agreed on the shared savings and revenue that the BESS and generation can create. And we fully benchmark that, so in real time we have measurement and verification protocols included within our leases, so that a third-party independent auditor can validate the savings that are created every month or every quarter. And we also leverage opportunities for on-site generation, solar, car park canopies and rooftop, and they also fall into the funding package, which I'll come back to. So what does a customer or what does a trust premises look like? Energy intensive, consumption above 5 gigawatt hours per annum, and spending typically more than £650,000 per annum on power. We work with freehold owners. If the site is under a leasehold, then we do need 15 years to run a headroom on that lease period. We also need to look at data. We need half-hour data. We need bills for the last year so that we can carry out an assessment, and that assessment will help us select the optimum configuration of battery energy storage for the site. That has to be an imperative to reduce energy costs, but I've never come across a site that doesn't want to do that. Also, we want to increase opportunities to reduce carbon emissions and help decarbonise the grid. I think the key thing here is capital retention. It's very important. Our proposals are completely capital free for a trust. So what are the key benefits? If you look at the revenue and savings, we're going to be able to provide between 5 and 10% savings against your baseline electricity costs. We're going to partner up with the grid to provide frequency and balancing services, which also can contribute to the stack of revenues. And we can offer power resilience and redundancy. So time of use on-site renewable generation, we can obviously shift the time of generation to more accurately match the time of consumption through storage. And there's no disruption to existing electricity supplies. So in terms of carbon benefit, we're going to shift from high carbon intensity grid periods to low carbon intensity grid periods. Typically, we're going to be charging the batteries up at night and we're going to be discharging the batteries during the day. We can obviously absorb solar generation, and we can demonstrate that CO2 reduction through a certification system if the client would like. All carbon benefits go to the trust or the customer. That's very important. So we leave all of those carbon benefits for the site to utilise in their own way. It's a zero capital cost, zero operational cost solution. And it's important also to point out that it's completely off balance sheet and does comply with IFRS 16 leases. A big advantage is that we've already undertaken and very nearly completed the legal documentation with Kingston. And I think what advantages we can bring is that we're very experienced as a developer, but we also have access to significant funds and a clear track record of delivery. We have operational sites that we can point to. The proposal is commercially aligned with a trust. You know, with the better we do, the better we optimize the battery and the delivery of those battery services, then it creates more benefit to the trust. This is just a quick graphic of how that shifting of peak period consumption or the shifting of the use of the battery can create carbon reduction, showing the different times of day and the different grid carbon intensity. Sorry, just go back, just to give you a quick graphic to show what a battery looks like. Essentially, it's a kitted out shipping container, 20 foot or 40 foot and fully modular. We can build up those modules to create a configuration of both power and energy. So on that basis, and conscious of time, I'm going to hand over now to Paul. Paul, just give me the nod when you want me to change slides, but I'm going to hand over to Paul Graham from Kingston Hospital Trust, and he can tell you a bit about the experiences he's had in our journey together to deliver the project at Kingston.
Thanks, Peter. Yeah, you can probably click on to the next bit. So why were we interested in this? It's partly because we'd just gone through the process of producing an energy efficiency project, which then didn't receive capital funding. So something that gives us energy efficiency at no cost seemed like a good idea. This model also overcomes some other barriers, like it's a lot largely outsourced, so a lot of the lack of priority and lack of management capacity are shifted onto EOS. Next slide. And again. Some of the important challenges we faced and solved together includes the lack of understanding. Obviously, most of our trust doesn't know where we get our energy from. So explaining to multiple committees and senior staff how this works, talking to EOS and explaining the proposition, even that it is no cost, took a while, but we've done that. We've also been in the contracting stage for quite a considerable time now. Our lawyers got in early, and we're pretty happy with the contract. We're almost at the point where we've agreed all the details. EOS have been very patient with that process, and it particularly helps that there's an M&V process included that will verify how this is going. Next one. And again. The benefits of this project, in my opinion, it's a solution that will work for any NHS organisation which is low on capital, so that's most of us, and is high on electricity consumption. It won't make our buildings more efficient. We've got some separate schemes going on that, but it will enable our systems to control demand at peak times and deliver savings and carbon benefits. It works well with on-site power generation from even CHP or from other sources, renewable things through the years. We've just got some solar panels and we're looking to maximise the effect of those. I hope the contract we've developed will be a useful model for other trusts, and we hope they will be able to use that. And I'm more than happy to share information about that, and once the BESS is set up, to host site visits if that would be useful. Back to you, Peter.
Great. I think one of the things, thanks, Paul. I think one of the things that comes out of dialogue with our customer base is, where's the catch? There isn't a catch, but I think it's important to point out where some of the engagement has to happen, and there is a journey to go on. I think it is genuinely zero cost, and it can create good and measurable savings, and all of the carbon obviously does go to the host, to the location. There are no catches, but some of the caveats to take note of, as I mentioned about the electricity bill, it needs to be big and it needs to be painful, and we can create more impact the larger the consumption. We've talked about the freehold state of the site. It also, I think, generally it works better in suburban and rural trust locations. Space is an issue, quite often in urban locations, it's difficult to find enough space, even for a couple of 40-foot shipping containers. So it's important to understand in the assessment process what the size of the site is and what the spatial logistics might be. I think Paul's explained, and we mentioned that the contracts have been worked through with Pinson Mason on the trust side and with our lawyers to create a very robustly structure and services agreement. So we can look at these sites, we can triage those sites and very quickly provide solutions and proposals once we get the basic level of information that we require to carry out those assessments. And I introduce Brian now, who's going to run through a few frequently asked questions.
Good afternoon, everyone. I'm going to act as a proxy for the audience, hopefully answering some of the questions that you might have. If there's enough time available, then we will solicit your own questions and try and answer them to the best of our ability. So what's just probably on everyone's mind is, what's the time frame from first meeting to a BESS Plus going live on a site? The answer is it's hugely variable, depending upon a number of things, including, is planning permission required? What's the complexity of the site? What's the complexity of the actual battery energy storage system, state of the market, etc. But as a working number, somewhere from call it 8 months to a year from first meeting to getting a battery energy storage system live, operational, and creating both carbon and cost savings for you. In terms of what happens at the end of the agreement, there are basically three opportunities to exit that contract successfully at the end of 15 years. We either sit down and agree to renew quite possibly with an energy refresh, a system refresh, because in 15 years, like most things, technology improves. It can be a request to extend the existing contract as is, or for whatever reason, if there's a request to terminate the contract, Energy Optimisation will come in, remove the kit, make good on any of the adjustments that they needed to make to the site, and leave the site in a workmanlike and tidy condition. Do you factor in it? A lot of people ask us, do you factor in an equipment battery refresh during the contract? The answer is absolutely. Generally around year 11, we will look to assess the state of the health of the batteries. And if they are falling below any sort of certain thresholds, we will remove those, repurpose them for domestic applications, and resell the battery energy storage system in order to achieve the highest savings possible for the rest of the contract. Question again, can I get details on the zero CapEx OpEx offering to present to my finance team? Absolutely, and I think Paul could chime in here. One of the real burning questions, and I heard it on other sessions earlier today on Pete's day-long set of sessions, is that funding is a real problem, and the determination of what's on balance sheet and off balance sheet is fulcrum in deciding which projects can go ahead. The EOS battery energy storage systems plus solar PV are true off-balance sheet, and for the accounting propeller heads, IFRS 16 compliant, which means they cross all the hurdles in order to be a true off-balance sheet, zero cost alternative for your trust. Another question is, does my facilities team have any in-life operational or management responsibilities with the battery energy storage system? The answer is, on a practical basis, no. There will be times when we will contact them to ask for access to the site to do either routine maintenance or break fix, or to swap something out. There is the requirement, which is relatively painless, generally once a quarter, to review the measurement and verification audit, which will show how the battery and associated solar worked during that period, what revenues, revenues it created by using it in interfacing with the grid, and then what savings it was able to achieve by arbitraging the charging up in the middle of the night when electricity is low cost, free, or sometimes they even pay you to take it, which is quite a nice thing to have. And then we determine what the relevant splits are between the trust and energy optimization.
Sorry to interrupt you, Brian, but we will need to wrap up in just a second, if that's okay.
Great stuff. So again, that's why we were worried about the Q&A. Let's just keep it really simple. We would love to hear from you, particularly for the larger trusts with consumption over 650,000 pounds a year in power. And we would very much welcome opening a dialogue and doing a site assessment for you at zero cost to you. Thank you very much.
Thanks everybody.
Pete. Thank you to Nick. Thanks, Peter and Paul. Really appreciate it. Enjoy your afternoon, and I hope this was helpful.
Thank you very much to all of you. That was really great. And apologies for needing to wrap you up. We are running slightly a few minutes behind time, but really interesting to hear from Paul with the case study as well, and how you guys have been working together. So please do use the chat, everyone. Please do use the Q&A to connect with everyone so far who's spoken. And thank you for everyone's patience with bearing with us while we're slightly behind. So I would like to introduce Tashiv from Eyesea Green, who will be speaking next. So take it away. We can see your slides. All good. But you are on mute. 1 out of 2 isn't bad.
Hello. A very good afternoon to all of you. Thank you very much for giving us the ability to present to you. It's been a wonderful session, actually, because all the companies above have basically made my job much easier, and there is a way in which I think iSense can work with every single company that had presented so far. So iSense is an energy management system that we think is the future, that already exists and is in commercial service. So iSense is ideal for you if you have an estate with new, old, or listed buildings, either separately or all together in one site. If you are uncertain about the correct technology strategy for your net zero plan, then iSense is ideal for you. And if your current energy management system is getting too complicated, too old, or too costly, iSense is great for you. So iSense is essentially a distributed energy management system. Conventionally, you have building management systems that have a large central site that zonally controls your entire estate. But what we've created here is an entire BMS into a little package that does room by room resolution, actually plug point by plug point resolution, that's scalable horizontally. So whether you have 1 room, 10 or 1,000 rooms, you can put iSense in one of them, every alternate one, or all of them, such that iSense can control either wet radiators, dry radiators, infrared panels, and it also controls other equipment that are connected to the plugs that work on temperature, humidity, occupancy, light intensity, or CO2. How the iSense pathway works is generally people look at centralized systems from BMS downwards, but we actually go from the point of utilization upwards. And that is every plug and radiator will have an iSense plug in it. Those will communicate wirelessly to a dedicated controller for that space. The controller has all of the sensory requirements to control these individual sync sources. And then that is sent to a global control platform. That is basically a dashboard that has all the information from all the sensors updated every 15 seconds to view occupancy and also calculates things like heat loss coefficients for a particular room, heat utilization, demand for heating or electricity in that room. And then if you want to, all these decentralized iSense units in all these rooms can speak to a building management system. And this is very important because if you have a building that all of a sudden requests 80% of the radiators to switch off or switch on, you can then instruct the building management system. Now, iSense was created such that you don't require the internet for operation. The internet allows you to have global control commands and advanced AI control of an entire estate. But if you do wish to disconnect it, it behaves like a little localized wireless distribution system. And that's very important because if there is any outage in data or communication, the iSense still works as it always would have. So the benefits of this system is, like one of the presenters said before, demand-based optimization. In order to get true optimization of utilization of energy, you need to use energy when you need energy. And when you don't need energy, you shouldn't use it. An example is your shed outside usually doesn't have any heating, and that's because people just go in there very quickly and comes out. Whereas your living room probably has the heating on all the time, but to optimize the demand based on parameters such as comfort, wellness, and also occupancy, you need to have a very comprehensive controller dedicated to that particular space. You have better control over your energy usage. iSense can work with wet radiators, dry radiators, underfloor heating simultaneously in a configuration where you can have boost heating when you initially just enter a room, or you can have a long sustained heating, both working simultaneously. The millimeter wave radar on iSense allows you to do spatial awareness of occupancy, and it works very well if you have direct heating sources such as infrared panels on walls, for example. So as the person walks along the room, the appropriate heating panel can heat up as following that person. You also have better accounting for your net zero plan because you have such high frequency accurate data on so many sensors. You can very well capture the energy usage in that particular space. And so you know if you've made any changes on retrofits, or if you have new buildings, or if you've changed your heating system, then you can directly evaluate the impact that that has towards your strategy plan towards net zero. It's also very cost effective. For its functionality, we can easily be an order of magnitude cheaper than a lot of the existing infrastructure out there, as well as the fact that you can have local or cloud operation. Now, this graph is just an illustration of a seminar room that demonstrates iSense on with and without iSense. The blue is basically a standard temperature controller in a building that has a timed schedule for its boiler, and that's in the blue. This is a seminar room, so it has about 6% occupancy, but usually is heated the entire duration. And the iSense is purple, showing that when the room is not occupied, the heating remains low, and only during occupancy does it ramp up the heating of the room, thus saving, in this particular case, more than 50% on the heating bill for that room. Our success so far, we're a Cambridge-based company, and we have very strong ties with Oxford University as well. So we have installations in colleges in Cambridge and Oxford, but also in London, Hull, and a few other universities. We have used our system in 4 different countries, and 2 of them are used to evaluate the living patterns of elderly people so that you can ensure that they slept for the right duration in their bedroom. They had a good amount of activity as they moved around the house, and also what time they had lunch in the kitchen or dinner. We have also installed in churches, schools, colleges, passive homes. Passive homes, very importantly, because they do need monitoring to ensure that the comfort index of that space is achieved. Listed buildings, as there is no wiring beside mains power that's required, can be installed in listed buildings very easily. Senior citizen homes, residential and public spaces. We have been in service for 18 months, especially in Cambridge, where we have almost entire college installations. There's more than 1,000 devices in the field. And also we have multiple nominations for Innovation of the Year by the Estates Gazette and Property Week. The award ceremony has not happened yet, so we can't say that we are winners, but we definitely are hoping that we get it. So our ask is, please, I know that everybody here has use for iSense in their building, so please contact us and give us a try. And we're very happy to speak to you to determine how iSense can work best for you. Thank you very much. I think that was quicker than usual.
Thank you. I'm not going to complain about that because we were slightly behind time. So thank you very much for being succinct, but really, really interesting. Yeah, really interesting innovation that you have there. And yeah, really interesting to see your successes so far. And best of luck with the awards. Do let us know how they go. Yeah, good luck. Thank you. So we are only running a few minutes behind now. We have caught up a little bit. So thank you everyone for your patience. Please do use the chat to reach out to Tashiv or any of the innovators and presenters that we've seen so far. But next up, we do have Joanne from Coolnomix. I can see Joanne on my screen, so she's raring to go. So I will hand over to you, Joanne. Thank you for being with us today.
No problem. Thank you very much for having me and for giving us the opportunity to obviously present to you about Coolnomix. Can I just check that my slides, I think my slides have disappeared, haven't they? Just bear with me. Are those slides showing now, Nicola?
Yes, we can see them.
Right, excellent. Just start this off. So yeah, as I said, thank you very much to everybody for allowing me the opportunity to present the Coolnomix innovation with you all. So I'm actually from NTH Solutions, who are a wholly owned subsidiary of the NHS. We are part of North Tees and Hartlepool NHS Foundation Trust. And there's a bit of a brief overview there of what actually our role is there within North Tees. We are the estates and facilities arm of the trust, and we deliver all of the facilities and estate services back to North Tees. Our summary remit as NTH Solution is to generate profits for investment back into NHS services by offering goods and services to either other NHS organisations or obviously any other wider organisations outside of healthcare. Innovation is a massive part of what we do here at NTH Solutions, a lot of which come from our own NHS staff on site. Other ones we kind of, come across as we are speaking to different markets and things like that. And that's where Coolnomix came from. It was something we trialled in our own trust a little while back now, and obviously had quite a bit of success with regards to that, which I will touch on shortly. But just to begin with, I'll give you a bit of a brief overview of what Coolnomix is. Some of you may have heard about this already, some may not have, but it's basically a fast fit, high intelligent thermostat. So it's designed to work with your air conditioning units and designed to ultimately reduce the energy consumption of those units, which, therefore leads to financial savings and efficiencies, which we're all striving towards at the moment, not only just because of, increasing costs, but also because of the carbon neutral side of things. So a little bit of info there. There is a small short video that I was hoping will work. So if I play this, it will tell you a bit more about how the technical side of things works, which is not my area of expertise. So I'll hopefully let this video explain all of that for me.
I don't think we're getting any sound if there's meant to be sound.
Right, just bear with me 1 second. Let me just.
Might need to select the share with audio when you're presenting.
Let me just, apologies people, just sort this out. Maybe it is a bit right. If I can't get it to work, I'll just, there we go, include the computer sound. Right, I should be back up and running now. Apologies for the delay. Start from the beginning. Video.
Coolnomix is a British-designed control technology for vapour compression cooling systems. It's a retrofit energy efficiency device that reduces your cooling system's energy use, carbon emissions, and improves temperature control. It works by controlling when cooling is turned on and off. Coolnomix uses a small control unit, 2 precision sensors, and an electric relay. The 2 sensors are placed in the supply and returned airflows and provide feedback to the control unit. The control unit sends signals to the cooling equipment to let it know the optimal time to run, in order to minimise energy consumption without affecting the output you need. To understand how Coolnomix works, imagine a vapour compression cooling system with indoor and outdoor units. The compressor is used to compress the refrigerant from a low-pressure saturated vapour to a high-pressure state. Next, the refrigerant is circulated through a condenser, where heat is removed from the system and dissipated to the surrounding environment. Then, the refrigerant flows through the expansion valve, causing a drop in the temperature and pressure. At the evaporator, heat is absorbed from the returned airflow, providing cooling for your space. The refrigerant then returns to the compressor, completing the cycle. The thermostat is generally used to control when the compressor is turned on and off. The compressor consumes most of the energy in your cooling system and runs longer than necessary. When this happens, the condenser cannot dissipate all the cooling load provided by the compressor, and excess energy is consumed. Coolnomix solves this problem by using a software algorithm we call Optimized Refrigerant Supply. It uses sensor readings and AI-based predictive analysis to determine when your space is being cooled to the target temperature and when the right amount of refrigerant has reached a high-pressure liquid state. This allows Coolnomix to cycle off the compressor at the optimal time, reducing overall energy consumption and significantly reducing your carbon emissions.
So obviously, depending on how technically minded you are, that may or may not have made sense. So in a nutshell, there's a couple of bullet points here that kind of explains it in more kind of simple terms. But yeah, the ultimate goal for these units is that it controls the running time of the compressor. So rather than the compressor be running all of the time, the device allows monitoring of the room temperature, and then obviously lets the compressor know when it should and shouldn't run, and it uses in the meantime any latent energy built up by the compressor throughout usage to keep the temperature to the desired level. And then obviously when that starts to tail off, that latent energy disappears, the compressor will kick back in again. So obviously then you reduce the amount of energy that you're using to run your compressor, which obviously then means it's going to cost less to run. There are some fail safes because obviously it's an electronic device, and it's obviously going to be connected to an air conditioning unit. So things to consider are things like the number of cycles. So if your compressor is switching on and off all of the time, is that going to impact the life cycle of the compressor? Well, actually, no, it should extend the life of it, if anything, because it's not running all of the time. But it also does limit it to 20 cycles per hour anyway. So in that respect, there shouldn't be any issue with the compressing side of things. The big question everybody obviously wants to know is actually what is the cost for something like this? Now there's some pricing up there which includes supply and installation, and then also how and why your return on investment is determined. Obviously, a lot of people will be paying completely different kilowatt hour rates for their electricity at the moment. A couple of the trials that have taken place so far have varied from 18 pence a kilowatt hour to 70 pence a kilowatt hour. And I'm going to talk you through an example trial in a second where they were paying 70 pence per kilowatt hour. So that's going to be one of the things that determines how much money you save, and therefore how quickly you get your money back on the purchasing of the units. Obviously, the size of the air conditioning unit and where it's located. So if it's in a data room, for example, I would imagine it's running a lot more frequently than somewhere else where it's just used as comfort cooling. And then also the age of the air conditioning unit. It can be used on even the most newer models. It just means probably that the saving won't be as vast, but there will still be a saving to be had on the newer units. So this is an anonymised trial report from a trust, obviously within the UK. As a general rule, a trial will last a month. So that allows us to do 2 weeks where we have the monitoring equipment and the Coolnomix devices installed. And for the first 2 weeks, would leave the Coolnomix devices turned off. And through that period of time, we're just purely monitoring the energy uses of the AC units as they would normally run. And then we switch the Coolnomix device on for the latter of the 2 weeks. And at the end of that, we do a comparison through the monitoring apps and the monitoring devices that are also installed as part of the trial to see what the difference has been between the first 2 weeks and the second 2 weeks. So in this case, there was a 28-day trial. They installed 2 units, one of which they were both placed in data rooms. But actually what you'll see is that although they were both data rooms, there was a slight difference in the results of this. So there's some charts here that give you a feel for what actually was achieved. So this first chart here is showing you what the energy consumption of the AC unit was, kilowatt hours, when the Coolnomix device was turned off in data room 1, and then the same in the other data room. And then once we turn Coolnomix on, what was the usage then? And then obviously in green, you can see the difference there. This is then applied into a table over here, which then obviously explains that in numerical form. So what the actual, figuratively speaking, savings were, and then the percentage of that. So overall, within this trust, on that trial, you can see that they saved, the energy consumption was reduced by 45% across those 2 units on trial. That's quite a significant saving there. And then obviously on this table below, it then applies that into, based on the 70 pence per kilowatt hour cost currently paid for electricity, what the financial implications of that would be in terms of how much they would save on a daily basis on 2 units, how much on a weekly basis on 2 units, and so on and so forth. And then alongside that, obviously, what's the carbon reduction potential as well? So you can see those figures there. Now, if this trust in particular were to then roll this system out across 100 AC units on their premises, now whether they've got 100 units on their premises obviously is entirely dependent. But if you apply a very similar calculation, simple calculation to those numbers, you'll see that potentially this trust alone could save around £72,000 a year if they were to install Coolnomix across all 100 AC units across their estate. So it's quite significant, and I'm sure we'd all like to save that amount of money. And a lot of things have to be taken into consideration here, as I've mentioned already. There was variation just from one data room to another, although data rooms as a rule tend to do the same thing. We've talked a little bit about obviously what might impact the difference in the variation of savings from one unit to another. So obviously we can offer trials to anybody that would like to go ahead and look at the potential for their own trust in saving some energy and some money, which we'd all like to do. We would help you obviously decide which would be the best AC units to trial that on by you providing us with your F-gas report. We would analyse that and we would suggest which units would be the best to trial the devices on. Once you've done the trial, we would provide you with a full report, which would give you all of the information like what you've just seen on the slides there with regards to that particular NHS trust. And at the end of that, if you think it's actually not something you want to proceed with, you can have the devices removed, or you can decide to keep them and include them in a wider purchase for more units, or just keep the ones that you opted for as part of the trial. And then that's it really. So a bit of a whistle-stop tour of Coolnomix. As Nicola's already said, if anybody does have any questions, by all means pop those in the chat box, or if anybody wants to get in touch regarding the potential for a trial or just to find out more information, I can arrange Teams calls with the engineers and things like that who know a bit more of the technical jargon and background to the way that the system works. But other than that, that's everything from me now. Thank you very much, everybody.
Perfect. That was brilliant. Thank you, Joanne. Yeah, really good overview of Coolnomix and a really good offer of a trial and how that might run if people are interested, which I hope they are. Please do connect with Joanne. So we have come to our final innovator. So hopefully we have Richard on the call. He's going to talk to us about Curo waste. Yeah, I can see Richard there. So thank you very much for joining us, Richard, and I will hand over to you. And you're on mute. There we go.
Sorry. Thank you, Nicola. Appreciate your time.
Thank you.
Okay, everybody, I'll just share my screen if that's okay.
Yeah, we can see them. Thank you.
Thanks, Nicola. Okay, thanks everybody for your time this afternoon, much appreciated. So I'm here just to provide an overview of the Curo waste management solution. It's a current partnership between Northumbria Healthcare and Peacock's Medical Group. Give you a bit of an idea of who we are. So we said we're a Northumbria Healthcare NHS Foundation Trust. So one of the largest geographical areas in the north of England. We provide a salary sacrifice car lease scheme. We're quite commercially and innovatively driven at Northumbria. We've had a salary sacrifice car lease scheme and home electronics for the past 15, 16 years now, which is in with about 50% of all NHS trusts, strong presence in council and local authority land, and solely provide the services to our public sector colleagues. So what we've identified here, we've been approached Peacock's Medical Group, who are a 120-year-old multi-award winning family-run group, who've been providing outstanding clinical and capital equipment services to the NHS for the last 75 years. So the familiarity there with NHS trusts and the medical environment. So it's a partnership between both organisations currently, and Curo actually means care in Latin. The idea hopefully being behind the Curo solution that we can bring some resilience back into the NHS, reduce reliance on third-party providers potentially, and look after the clinical waste that we're currently generating. So one of the reasons the solution came about, Curo looked into the fact that the medical waste has become one of a hospital's highest financial and environmental costs. So specifically here, we're looking at orange and tiger bag waste. During handling and disposal of and removal of, it can be hazardous and can pose a high risk. Medical waste is transported or incinerated off-site, and then also landfill currently, resulting in increased CO2 emissions year on year through that landfill process. The waste can also only be stored on site for a maximum of 5 days. And the waste that's generated, circa 150, according to the ARIC data, 2019, circa 153,000 tonnes of such waste is generated across acute trusts and maternity beds, creating circa 108,000 tonnes of CO2 per annum. And of course, in line with all that, waste is a huge cost to all NHS trusts. So hopefully with a similar solution, we can have a look at potentially having a reduction on the financial impact of the waste and how it's managed in its current process. So the Curo systems has a combined existing and patented capital equipment and technology, which creates an on-site waste processing and sterilising and shredding system. It's compact, efficient, safe and compliant, and easy to operate. The system's not one size fits all. They are scalable and modular depending upon the amount of waste that's generated by individual sites. And of course, we're acutely aware of restrictions with current real estate footprints and things like that. So we can try and make it manageable and work within the current environment that's available on the estate. Some of the features: it helps to reduce the volume of waste that's loaded into the system, to reduce the amount of disposable waste that needs collecting. The hazardous waste is registered inert once it's gone through the sterilisation system and shredded, hopefully helping to reduce the CO2 emissions. Easy to use, including easy setup. Indeed, the Curo team are on standby and help to manage the install and process throughout and provide the staff training. Small but scalable, working within the real estate footprint, as we've discussed, with configurable options to try to work within that footprint. So therefore, it leads to a bespoke design and implementation for each hospital site. Site survey will be carried out by the Curo team. Come and have a look at current facilities and what's available and how a unit could be accommodated within that area. Low energy system using some patented Aqua Zero system that consumes 20 litres of water per cycle, a cycle taking circa 35 to 40 minutes for each cycle. It becomes part of your current waste movement process in that bins are emptied on wards as normal, orange and stripy bags. We do provide, or part of the solution is there's alternative bags that are provided that are transparent on one side. So you can actually see in and see the kind of waste that's being thrown into the orange and stripy bag, and then they've got the orange down one side and the tiger feature down the other side. The bags are also designed as well, therefore, to be porous, but only porous in the matter that the way the unit works, and the steam can then reduce the bags and take away the bag matter. The machines are plenty of longevity. The machines will last for up to 10 years, and it meets a lot of the compliant requirements within the waste standards. There's also an innovative waste and weighing tracking software throughout the system. So as the waste has come down from the wards through the normal process as normal, before it's loaded into the machine, it's weighed and barcoded up, and then it goes through and scanned, thus allowing to record the weight of the waste as it goes through, and then how it's been reduced in size by up to 70% as it's gone through the sterilisation process and shredded at the other end. So we've got a current waste process that's similar to the presentation at the top there, in that the waste is coming down from the wards in the usual manner. It's currently being collected by third-party providers, quite frequently from the private sector, who come on site, collect waste however many times a day, a week, and remove that waste. That obviously generates a CO2 in that happening. The waste is then either taken away to be incinerated or indeed put into landfill, with landfill creating CO2 year on year while ever it's in the ground. So with the Curo process, the waste will come down in the normal manner. It will go through the Curo unit, barcoded up, weighed, reduced in size through the sterilisation process, and then the matter after the shredding is then registered as inert. So we've reduced the amount of waste we've generated, so there's less to be collected. The hope being therefore then that can be disposed of via your normal domestic waste stream, or indeed even compacted, so there's less to be collected again. So with less collections and such and things like that, with lorries coming onto site, hopefully we're reducing the financial burden and the invoices that are coming into NHS Trust for the collection of that waste. The inert matter is known as flock. Curo are currently working on potential and investigating what solutions there may be for that flock and how it could possibly be reused thereafter in its current state. That's an ongoing process with lots of research that they're still doing into that. But all things prevailing, ultimately, potentially we could have a solution for that inert matter and that flock at some point in the future with that continued research. So the idea has already sort of been around for the last 12 to 18 months. There is an install that has taken place at NHS Orkney. Appreciate it's on a slightly smaller scale and an island just off the UK. But Orkney have invested in the solution and are currently operating and processing their waste through the Curo unit. So they had a business case approved. The Curo team worked closely with the team there at NHS Orkney, as well as working very closely with the governing body, SEPA. So during that process, of course, as well, there's been a lot of learnings that Curo have taken on board with regards to permitting and the requirements that are required for the installs. So some of the main benefits to Orkney now are that they can process their orange and stripy bag waste on site and within the timelines in the EPR guidelines. And all waste created and processed is accurately recorded and meets SEPA regulations. So with the software facility that's available through the Curo unit, hopefully it's helping to improve the reporting on ERIC data and things like that as well, and much more accurate reporting of that data. So in summary, it's an innovative end-to-end sustainable solution for orange and tiger bag waste. There's a fully managed delivery and installation process of the system. So the Curo team are on standby throughout the process to work closely with the estates, facilities, sustainability leads, finance guys throughout the whole process and installation and leading up to that point for decisions to be made as to whether a Curo solution would be right for the acute trust. Design, scoping and environmental education and training for waste managers and NHS staff to support the solution, ensuring buy-in and waste is managed correctly right at the start of the process. So by having the slightly different bags in the bins on the wards, you might be able to identify that there's a pizza box being thrown in there and things like that. And we're all respectful that nurses and staff on wards are under pressure, but but granted that, you know, if there's a small education piece to be had there, we can just ensure that waste is being segregated appropriately. Support services, maintenance, testing and validation and permit support, the accurate tracking and software system that we've discussed. They'll also help, the Curo team will also help compile a business case to support a potential requirement for an install. Helps reduce the amount of waste reaching landfill and being incinerated to hopefully help reduce the CO2. There's the reduction in the transport and collection costs as a result, reduced volume of waste needs to be collected. The ambition being it will also give NHS Trust control of waste again, improving process and segregation. And as we alluded to earlier on, hopefully reducing reliance on those third-party providers having to come on site and generating that CO2 footprint with the collections and the invoice and the costs associated with those collections as well. Compliant and risk averse, and should hopefully hoping to provide assurance on the solution. I'd just like to thank you all for your time today, much appreciated. Obviously, if anybody wants to reach out thereafter, the Curo team can be on standby to answer any questions or proceed further with any inquiries that you may have. Thank you for your time.
Perfect. Thank you, Richard. That was really interesting, kind of end-to-end process overview of the solution and the great benefits that Orkney are seeing. So yes, please do connect with Richard if you'd like any further information. I'm aware that we are at 3 o'clock. We've had so much brilliant information and presentations for all of our innovators. So thank you so much to everyone who's spoken and everyone who's joined us to listen to those presentations. And as I say, please do connect with everyone on the call who you would like to, more info or to work with further in the future. I will stop there because we are now 1 minute over, but please do join us in the other room for the final roundtable and wrapping up of today's event. But thank you very much to everyone who's joined. Any questions that haven't been answered that are in the chat or the Q&A, we will collate and send out afterwards because we have run out of time for any questions. But thank you very much, everyone, and we'll see you soon.